You heard about this discovery of 7 new exoplanets around a single star? Here's a resource that might help you if you want to cover this subject in your classroom. So what is this discovery exactly? Well, we knew the star TRAPPIST-1 had exoplanets around it, but this new discovery brings the number up to 7. And these are terrestrial planets. They're not gas giants like Jupiter. Terrestrial means they're similar in size and probably in composition to the Earth. However, we don't know what they look like, so this is really an illustration. It's not a picture. It's an artist's perspective on what these worlds might look like, but we don't really know what they look like because we've never seen them. But then you might wonder, how do we know they exist? How do we know they're there if we've never seen them directly? Scientists use different methods to find exoplanets, but the method that was used in this case is by looking at the transits. So if you look at the amount of light we receive from the star, that amount of light will go down a little bit when the planet passes right between us and the star. So we actually don't see the star and the planet the way we see in this animation. All we see is what we call the light curve. And when we see a dip like this in the light curve, then we know it's probably a planet that passed between us and the star. So if that dip happens regularly, then we know it's because there's a planet in orbit around that star. So that's the method that was used here. To show you the system with the star TRAPPIST-1 and its 7 planets, I will use the program Eyes on Exoplanets. This is very well done. It's by NASA, and you can check it out. You can download it for free, and it's really worth it. It's really, really well done. So you can see in the center of the star TRAPPIST-1 and its 7 planets in orbit around it. And you can see the names are not very original. We just give it a letter. We just assign a letter to all the planets. We can have more information about this system. So the star TRAPPIST-1 is actually at a distance of 39 light years away from us. This is very close. This is in our stellar neighborhood, and it's a reason why the system is so interesting, because we'll be able to study these exoplanets in more details, and it's never been possible before. However, even though the star is relatively close to us, it is not visible to the naked eye because it's much smaller and not as hot as the sun, so it does not emit enough light, and then we don't see it, even though it's only 39 light years away. But if you are curious, it's towards the constellation Aquarius in our sky. Now, something we can do in this program is compare the system TRAPPIST-1 with our own solar system. You can see here how the planets are all very close to their star. This is a planet Mercury here. So just imagine, this system has 7 planets in a region equivalent to just a tiny fraction of our own solar system. You might think they're all very hot because they're so close to their star, but in fact they're not, because their star does not emit as much heat and light as our own sun. So let's make the habitable zone appear here. So the new zone that appeared is kind of bluish green here is what we call the habitable zone. It's not a very good name, and I'll explain why in a minute, but this gives you the region around the star where the temperatures might be right for liquid water. If a planet is very close to its star, then it would be very hot, and water would not exist in its liquid state. If a planet is very far away from its star, then if there was water on this planet, it would be solid ice. But in this zone here, the temperatures might be just right to have liquid water. Now, we don't know if these planets have water on them, but if there was water, then it could be in the liquid form, which is very interesting because that's a condition that's necessary for life as we know it. But the term habitable zone is misleading. It doesn't mean we could live there. It doesn't mean the conditions are perfect for us to live there, and it doesn't mean there's life. It's a term used by astronomers to indicate the region around the star where the temperatures would be right to have liquid water. Something interesting we can do with Eyes on Exoplanets is that we can zoom in on individual planets. And let's go visit the planet F. First of all, you can compare with the Earth, so you can compare the size, and you can see it's pretty much the same size as the Earth. Obviously, this is not what the real surface would look like. It's, again, an artist's view on this world, but this world is interesting because based on the mass that we have so far, it's not an exact measurement, but based on the mass that we have now, we think it might be an ocean world, a world completely of water. And you can see that here. One side would be completely ice, and the side that would be facing the star would actually be liquid water. So again, we're not sure that's what it looks like. It probably doesn't look exactly like this, in fact, but it's interesting to visit the different worlds with this program, Eyes on Exoplanets. So I highly recommend you try it out. Now, if we come back here, then the picture we see here is the view from one of the planets. Again, an artist's concept of what the view might be like. But what I find interesting in this drawing is that we can see the other planets around the star. They're so close to one another that it would appear as big as the moon in their sky. So it'd be quite interesting to see the different planets like this in the sky. But again, this is not a picture. This is actually based on the world that it shows you, the F planet, and it would be at the limit between the frozen side and the water side of it. So why is this discovery important? Well, it's the first system with so many terrestrial planets, including 3 in the habitable zone. So it is something we've never heard of before. It's also a system that's very close to us, so it will allow us to study these exoplanets in unprecedented details. And it's an excellent target to study the atmospheres of terrestrial planets. And that's something we'll hear about more and more in the next few years. So I want to keep your eyes open for this. It's worth talking about the limits to our knowledge. So what we don't know about these planets. First of all, we don't know what the planets really look like. With this press release, they created very nice images of the planets, but these are not real pictures. You have to keep that in mind when you discuss the system. We also don't know what the conditions at the surface of the planets are like. Even the planets within the habitable zone, we don't know if there's water at the surface, so even if they're in the right temperature range to have liquid water, they might not have water. And it really depends on their atmosphere. That's why it's going to be so interesting to study the atmospheres of these planets in the next few years. We don't know if there is life, and we don't know if we could survive on these planets. And this we have to keep in mind, especially with the term habitable zone, which can be very misleading. But this is a very interesting system, and it will be worth following the new discoveries in the next few years. So if you like this video, you can download the PowerPoint presentation that goes with it, so you can use it in your class. And if you have other questions you'd like to ask us, then you can send us an email. You'll find it on our website, or use the hashtag AskDUAstro on Twitter. We hope this was interesting and it will be useful to you, and we hope to see you next time.